Every part of this that isn't an electronic came off my 3D printer, and I designed everything from scratch in CAD. And if you recall from the last video, I had never flown a drone, and designing it was just something I've not even thought about. So this video is exactly how I got this made, and spoiler alert, it doesn't fly yet, more on that later. All right, let's do a quick recap first. I had never flown a drone, so I spent a week crashing in a simulator where crashing is pretty much free, and the whole time, the box of the real parts of the drone were just sitting on my desk. And the bar was set out loud. It was gonna be a 3-inch quadcopter, which means 4 motors, 3-inch wide, and it was gonna be under 250 grams of weight, because that means I don't have to register it with the government, and it needs to have at least 3 minutes of flight time. So anything that is not an electronic and I can 3D print, I will, and every single file that I build myself will go open source. So this video is exactly where that box that has been sitting on my desk gets open, and then we get real and we start building stuff. Now, there are 4 things on a drone you genuinely cannot print. It's the motors, a battery, a radio, and the brain. So this is gonna be the brains of the drone. Now, I did look into it and I asked AI, I was like, why can I not just use like a Raspberry Pi instead of this thing? The answer is delay. On a Raspberry Pi, your instructions go through an operating system first. On this, there's no operating system whatsoever. The hardware talks straight to the motors, and a drone falling out of the sky doesn't really wait for your operating system to schedule anything. And also, this is so much more lighter. Our goal of getting to a 250-gram drone is possible because stuff like this is much lighter than the Raspberry Pi. And then we have this radio module that also goes on the drone, and this is the one that talks to the controller and then tell the drone what I am signaling it. And then we have these motors. We got these 4 motors. These are very tiny. These are surprisingly small, and I did not know motors could go that small, but I'm sure there are ones that are much smaller than this. And for this specific project, we're making such a small drone that we really don't need big motors. And the bigger the motors means more battery you need, and then the weight gets heavier, and we want to keep it under 250 grams. So considering all of these constraints, these motors were the perfect fit. And then we have this lithium polymer battery. It's a 650 milliamp hour battery, and it has 4 cells inside of it, so 4 unique cells. And the whole job of this battery specifically, and why it does look so much weirder than all other normal batteries, is it is supposed to discharge current at an extremely fast rate. So imagine I'm flying the drone and I just need it to go really fast in some direction. Normal batteries cannot discharge that fast, but this one is specifically made to be discharged really fast. So this is why we have this battery, and it is pretty small, so it doesn't add too much weight, but hopefully, according to my calculations, it should actually give 11 minutes of flight time. But I'm sure there will be some things we need to adjust, and it should give at least 3 minutes, which is our goal here. And lastly, we have these propellers. Now, I was thinking if I could like 3D print this, but I don't think I can, just because how smooth these are. I think 3D printing would just not give us that, but one day I might just try 3D printing these propellers. And these have to be so smooth on the surface so that the air does not have a lot of drag on them and can just smoothly give us a nice lift on our drone. To design a frame, you first need 3D models of all of this. Not photos, but actual models. So you can design a body around it and you know everything fits before you actually end up printing it. And for some of them, I did not have those. Actually, no one had those. I mean, at least not on the open internet. So I had to go figure out how to find all of these models first. Now there's a site called GrabCAD where people upload models that they have made. We did find the radio antenna CAD model and the exact motors that we're using. That's good. Shout out to Riley Entropy, where this person is. You really saved my day here. But the flight controller, the battery, the propellers, nothing. Now, I started with the lazy thing and hoping that the AI can just make the flight controller board so it can just get the very basics of the dimensions right, like the height, the width, where the screws go, and where the USB is. That's all I needed. So I was hoping I would have Claude write me a detailed prompt describing what the board should really look like, and I pasted it into the Onshape AI, and I just hit go, sat back, and to be fair, it sort of worked. It made the holes for the screws. Oh, it made the little USB. That one, that's just not correct. Yeah, look at that. USB-C, not in the middle, to the side. Why is it making the USB-C right in the middle right here? I'm just gonna make this board myself. It was 2 days of this where I measured the thing and then I modeled the thing and then I would check the model against the thing. So this took me a lot of iterations to make sure every single measurement for the board comes out to be perfect. So when I'm designing the mounting holes for this board on the drone, nothing can go wrong. Same story with the battery. There was one model online that looked close, so I grabbed it. And then I did something that sounds ridiculous but genuinely saved me. So I loaded it into my Apple Vision Pro at full size and held it with the real battery right up next to it. But that was not accurate for the battery that I was using. So I built this one from scratch instead. And after a couple iterations, I got the dimensions exactly correct and where the cables come out from, and after comparing it, I got it to the real size. A virtual reality headset like this can catch big errors, but for the small ones, there's only really one method, and it is slower, but it is to print a dumb plastic copy of the real part and just compare it, see how it compares to the real one, and then make adjustments accordingly. If I try to align it, the top is aligned, but the bottom does not align. And I think I do know why that's happening. And this is why exactly I do this, because very minor things that in CAD you will not see it, but once you actually print it out and put it in your hand, you will actually see the difference. It's off by like a millimeter, if not 2. And then I just went back to CAD, made some minor adjustments, and after a couple times, I got the dimensions right. So now you may be thinking, what's the size of this drone gonna be? Like I mentioned before, it's going to be a 3-inch drone, and by 3 inches, I mean the diameter of the propellers is 3 inches. Please work, loft. Oh yeah, heck yeah. That work? Oh yes, okay. That looks good. I mean, it's not perfect, but that looks good. I'll take it. So the whole frame is really just a device for holding 4 3-inch circles that are far enough apart that they never touch each other. And there was no propeller model online either, so I built one of those from scratch too, and out of splines and a lot of lofts and a lot of guessing. The final version that I finally was happy with, that I wanted to assemble all the parts onto and then start to test the flying, was version number 8. Now, from version number 1 to version number 8 took about 4 days, where I moved the battery, I moved the motors, make the entire frame thicker so it doesn't have as many vibrations from the motors going in. Well, first the flight controller board was actually mounted on top of the drone and the battery was at the bottom, because I thought that would make the drone balance a little better. But as I thought through more and with the design process, I actually ended up mounting the flight controller board below the drone and the battery above. And that way, when I need to swap a battery, it's actually super simple for me to just swap it in. And all the electronics are now at the bottom, and getting the cables routed to the motors, everything just got way simpler. Okay, so next is the smoke stopper, and this is key because this is what sits between your battery and the flight controller. So if anything goes wrong electrically, it's the only one that takes a hit instead of your expensive board. And even if one connection is wrong and you push current through it, you get magic smoke. And guess what we don't want? That magic smoke. So currently I'm planning to keep this on the drone during the flight, so if there's any overcurrent situation in the air, it doesn't just torch everything. So this $12 is probably one of the best insurance policy on this build. And by this point, I had everything modeled, measured, and designed. I had printed 8 versions of this frame, tweaking the stiffness, adjusting tolerances, and even printing the last one that you're seeing right now in ASA filament, because I thought it'd be much stronger. Then once all this design process was done, now it was time to find out if all of it actually worked. I sat down and I started assembling everything. The motors, the batteries, the flight controller, the radio board, all onto the drone for the first time ever. And this was the moment where every small decision I've made throughout this whole build was going to be tested. If everything fit, I was flying. But if it did not, I was going back to the drawing board. So let's get assembling. For soldering the electronics, I actually did everything with Claude right next to me on my iPad. So I would describe everything that I was looking at, all of the manuals in front of me, and I would verbally describe it and tell Claude exactly what I was looking at, and then it would help me figure out which pad to solder what cable on. And I want to show you some moments of that, because together they're some of the most useful things I learned on this project. The first one is it telling me which pads on the board to solder the receiver to, and it has the 2 rows backwards.
6th from left. Can you confirm you can see all 4 of those pads?
I think you confused. The top row has 4 pads, the bottom row has 6 pads.
You're right. I got it backwards.
Could you double check? Don't just say you're right. I just want you to be 100% sure. So cross check. Ask me questions.
You're absolutely right. Let me be certain before you solder anything.
That instant right there where it said you're right is the exact thing to watch for. It'll say whether you're right or not, and it agrees just with the last confident voice that it heard, which was mine. So I made it work for it, and it did it. It slowed down, and it started asking me questions instead of just answering them, which mattered a lot more in just about an hour. Well, these seem to be connected to each other. I mean, I'm tapping between two different pads and it beeps. Is that normal?
It's not normal. Motor phases should not beep. A beep between two motor pads means there's a short circuit. Before you power anything on, we need to fix this. Which motor is beeping?
Pretty much all of them, bro.
Okay, that's a problem. All 4 motors are showing shorts between their phase wires.
So I supposedly have 4 short circuits on a board, and I spent an hour soldering, and I'm being told not to power it on? Yeah, I just didn't buy it. Not because I know better, but because the shape of the answer was just wrong. 4 separate hand soldered joints do not fail in the exact same way. I mean, literally, if I connect to any 2 different pads on all 4, it's beeping. So is the board shorted somewhere? I mean, I'm not that bad at soldering, so in no way it is shorting on every single one of them.
You're right. If all 4 motors are beeping between every pair of pads, it's almost certainly not 4 separate solder bridges. That's too coincidental. Let me ask, are those motor pads somehow electrically connected together on the board itself? Okay.
Oh, okay.
That makes sense now. Yes, that's completely normal. Each motor's 3 pads are connected together internally.
There was never anything wrong. Those 3 pads are actually wired together inside the board, and they're supposed to be. I spent 20 minutes trying to figure out this contact behavior, and the only reason that it did not cost me any money is because I actually pushed back a lot before actually getting to the final conclusion on figuring out why I was actually beeping the whole time. So here's the actual lesson. Building hardware with AI in your ear is genuinely very helpful when it knows more about the parts that you're using than you do. But it's pretty useless for parts that it does not know anything about from its training data or find anything on the internet. And it will not tell you which one you're in. So the whole skill is making it ask you questions because you're the one holding the actual thing. All right, moment of truth. Power supply is at 16.8 volts, the current limited to 2 amps running through the smoke stopper, and the propellers are nowhere near, so nothing starts spinning frantically. And voila, that is green light on the smoke stopper. No smoke, and it is pulling 1/10 of an amp, so it is success. This is absolutely fantastic, the fact that it just worked on my first try. So the hard part was done, but then I lost 2 weeks to problems that had nothing to do with the drone. The motors won't spin, literally none of them. And the radio receiver had never been paired to my controller, so Betaflight won't run a motor without a valid radio link. It's a good safety measure, but it really did feel personal. So the pairing should only take 30 seconds, but it did not. Months earlier, I'd flashed a new firmware onto this controller for the simulator that I was working on, and then that reshuffled every single menu. So every guide I found online was pointing at buttons that did not exist on my screen. So then I just put the controller back to the settings that it came with. Wouldn't you know, it just worked. And then a second issue came up where any settings that I would put on the flight controller on how it should behave, all of that would just not save. Every time I would power the board off and then turn it back on again, it had just forgotten everything I just told it. It somehow corrupted the configuration memory on the flight controller board, so it needed a full chip erase. So if your settings won't stick, it might not be you, but eventually, and I do mean eventually, arming. Oh. As soon as I arm it, moved. Oh, armed. It is moving. Oh, and it died.
Telemetry lost.
I think the battery just died. 10 seconds of victory, and then the battery just gave out. Still counted though. And then the propellers are the last thing to go on, and that is very much on purpose, because if the propellers start moving and you did not intend it to, they can really hurt you. I think there is a way to exactly put these on. That's fine. Let's just put all of these on and see what happens. All right, all the propellers are connected. And this is how our first version looks like. Not perfect by any measure, but this is my first drone that may not even ever fly. But it's worth trying. Our goal was to be under 250 and it's definitely gonna be under 164. Okay, that was about 2 weeks of me consistently working on going from knowing nothing about drones to having a drone built. Now, I don't know if it's gonna fly like I just said, but we're gonna try that in the next video. This one has just gotten a little too long, and if you watch this video till the end, it is very exciting for me to work on a project of this scale, getting to learn so many new things in such a short amount of time. So thank you for watching, and I will see you in the next one where we definitely will get this drone to fly. Until next time.